Welcome to Module 2. This module covers Chapter 4 and 5 from your textbook. In this module, we will explore SPSS specifically. So we will evaluate differences in different types of, showing frequency, how to show different bars, bar charts, scatter plots. So we will explore graphs and bars using SPSS. So chapter 4 is about SPSS environment. So whenever you download SPSS and you double click on the SPSS icon, there will be a window like this pops up. So here on the left side, it shows the previous data sets you have been working on. So if you haven't worked on any data set, any file, this recent files box will be empty. But this is easier for SPSS users to find their recent files, just clicking the file name here. So anyway, so if you don't have any file, any recent file, you can just click on new data set, and then it will like open a new SPSS data set. So SPSS has three windows. We have data view, we have variable view, and then we have output view. So here in this picture, we have data view. This is similar to Excel file or spreadsheet. So you have different columns and different rows, and there are different cells, and you will see numbers or values, data points, scores, rise scores inside each cell. This is just similar to Excel file or Google spreadsheet. So remember, as I mentioned, different columns represent different variables, and rows, each row represents different observations, different individuals, different objects. It can be anything. It can be animals or humans or whatever. So each row represents distinct people, individuals, and each column represents different variables. So this is data view. And then we have variable view. So unlike other statistical software like Stata, SAS, or Python, there is no variable view. So SPSS is more friendly user. In variable view, you would see the names of different variables, like the names for different columns. So we won't see observations, raw scores here in variable view because it says variable view. So you will see the name and the values, the type label, or the type of the variable here in this variable view. So we have name, type, the width, decimals, label, values, columns, align. So you would put different variables name in each row here. So the first column is name. So you would put different variables. For instance, I would say the row number 1 should be participant ID or study ID or whatever, individual ID, for example. The second variable is body weight. 3 is height, 4 is BMI, 5 is favorite food, 6 is gender, 7 is race, age, so on and so forth. And then the second column is type of the variable. So the type can be numeric, like height, body weight, BMI, can be string like letters, the name of the participant, for instance, your favorite car can be string. My favorite car is Ford, for example, or Chevy, for instance. Favorite color can be red, blue, that's a string. Currency, that's like currency, that's one of the types of variables. And date, for example, I would say the variable is date of birth. And I can check the change the type of the variable to date, and then I can record it as uh, August 21st, 2001, for example. So this is how we will change the type of the variable. So I will show you how to do that. And I apologize if pictures are blurry. This is from your textbook. So here is the variable type. So these are different boxes. So we have string, date, numeric, so on and so forth. This is kind of defining uh, a date variable, defining a numeric variable, defining a string variable. So as I said, whenever we enter data into SPSS, there are a couple of ways to enter data. First, we can have our Excel file or spreadsheet. So our data points, everything is saved in Excel file. And then I can import that Excel file to SPSS. Or I can just like entering data one by one to SPSS. So the first method is much easier, and it's really quick, fast, time saving. But let's say we have a empty and blank SPSS data file, and I want to enter data to that SPSS. Um, Remember, as I said, each row represents observations, data points, raw scores, individuals, people, person, whatever. And variables, they represent the same thing, but they are different variables. Uh, so here in this example, so we have ID. ID is one of our first variable in first column. And then we have, for example, date of birth, education level, job category, salary. These are different variables, and they go in different columns. And each row represents different individuals. They go in rows. And sometimes in experimental research, we have repeated measures. In that case, again, each row represents individuals, and the columns represents data points. For example, first column is ID number, study ID, participant ID, and the columns across the SPSS data file represents the different time points. Baseline, 3 months, 6 months, 12 months, 24 months, so on and so forth. Let's say I have a string variable. I have a categorical variable like gender, like race, education level, job category, favorite color, favorite animal, favorite car, um, BMI, for example, if I want to code BMI as a categorical variable. So here in data type, I can put it as numeric, and then I put it label. For example, I would say BMI in the name column, and in the label I would say body mass index, and then I can assign values. So if you click on this small blue box, which has three dots inside it. If you click on that, there will be a separate window popping up, and then you can assign numbers to each levels of that categorical variable. So let's say I have race or gender, and if I click on this small box here, this window pops up. Then I can say value 1 is man, value 2 is woman, value 3 is binary, whatever. Then I can assign values to that specific categorical um, variable. And this is syntax window in SPSS. Instead of entering data by importing data from Excel file or a spreadsheet, or entering data one by one to each row and each cell, each column, I can write a syntax. It's just writing code in R, in SAS, in Stata, in Python. And then I can run this code, and it will, it's called syntax commands. And we have a command area. Then whenever I run this code, it will execute the code, the commands, and I would see my SPSS data file. And also I can run analysis using SPSS syntax. Instead of like clicking on analyze option here on top, or clicking on graphs to draw graphs, to transform data and whatever, I can write code here in syntax commands. And whenever I run the code, it will execute the commands, and I will see the output window. Sometimes, if you need SPSS permission, for example, you need admin permission in order to open SPSS file. This is a way uh, to solve it, to prevent it, to open it without having any problem, any issue, any error message. So this works in Windows. So you need to click the Start menu on your computer and then type SPSS. And you need to find IBM SPSS on your computer, right click on it, and then click Run as administrator. So it's kind of preventing from any error message or warning message. So you usually only do this when SPSS is not working normally. SPSS won't open, you get an error like access denied, you can't save output or datasets. SPSS crashes when trying to install something. You can use this option. Just find IBM SPSS file by clicking on the Start menu, and then right click on it, click on Run as administrator. So that was all about SPSS environment. And after talking about chapter 5, I will show you how to work with SPSS uh, in depth. So in this chapter, uh, we will learn how to present data using different types of bars, graphs, um, and we will utilize chart builder using SPSS, and we will learn how to create graphs, different types of graphs like histograms, box plots, error bar charts, scatter plots. Remember, there are different types of graphs you can use SPSS, but these are the most common types. So any graph on research articles, they need to show the data, include the reader to think about the data being presented. avoid distorting the data, present many numbers with minimum ink, make large data sets, encourage the reader to compare different pieces of data and reveal data. Do not hide or conceal any data. Why is this graph bad? So this is a 3D graph. It looks interesting and fascinating at first, but whenever I look at this graph and I try to interpret data, I don't have enough information about these, like bars. For example, we have like this, these are like 95% confidence interval. These are error bars, but I cannot see the number, like the upper level of 95% confidence interval. What number indicates the upper level of 95% confidence interval, or what number indicates the lower uh, level of a 95% confidence interval? So I cannot interpret this data actually. I don't see any clear data to interpret this graph. And again, this one is also bad data. So this article puts two graphs besides each other, but here on the left side, I'm not sure what this y-axis is. What about x-axis? It seems like years, 2004, 2005, 2006, but I'm not sure about the y-axis. It says millions, so it's like 10 millions. And then on the right side, we have different numbers. And here on the right side, the uh, the bars shows a huge difference. But if you read the numbers, they are very close to each other. The Times, the Daily Telegraph, it's like 485,000, and the Daily Telegraph is 446,000. So there is not a big difference. But whenever I read this, um, whenever I look at this graph, um, I would say there is a huge difference between the Times and the Daily Telegraph. So it doesn't show a clear data here to readers. And this one is average monthly temperature. So here the data points are not below 20. So I don't need 10 and 0 first. Second of all, it shows average monthly temperature in Fahrenheit, and it shows increase, but it only shows the first 6 months of the year. So I don't have data to interpret for the next 6 months of the year. So it doesn't show complete data here for to reader to interpret. And this one, it says the diminishing financial return of higher education. And on the x-axis, the intervals are not equal. So it's like 64, 70, 80, 90, and 1000, 2010. So it doesn't show an equal intervals on x-axis. This graph is better than others because it shows data points first, and it shows the types of obsession. The x-axis, the y-axis is clear. It says number of obsessions per day, and the x-axis is also clear. We have CBT, BT, no treatment. It's type of therapy. And then it shows standard deviation or 95% confidence interval, and I can see the values. I can interpret this data clearly. This is deceiving the reader. So it's normal vision compared to Minister of Cheese version. So in normal version, the number of nightmares in a week is much higher than number of nightmares in a week in Minister of Cheese version. So it's kind of deceiving the reader by not showing uh, it's like the y-axis here, it's from 0 to 12.5, but on the right side, the y-axis is from 0 to 50. So as a reader, I would say, oh, that's good. The number of nightmares in a week is not higher in cheese group. But that's not true because on the left side, as a reader, I would say, I would conclude that number of nightmares in a week in cheese group is much higher. So it's kind of deceiving the reader. I don't need 50, 40, 30, 20, um, lines for cheese group for the number of nightmares in a week because there is no data there. So this is deceiving the reader. So using SPSS, we can build charts. We can build graphs. So there is an option on top of the SPSS. It says Chart Builder. So if you click on this, there is a window like this pops up, and then you can choose different types of graphs, charts you want to create, and it shows x-axis, y-axis. So you can like these are drop zones, and you can just drag the variables and like release it to the drop zones. And I will show you how to do that. Um, so these are basic elements, like choosing axis, choose elements. As you can see, there are different types of charts. We have like radio chart. A radio chart is useful when representing healthy eating index, but most of the time we just use uh, a, a two-dimensional chart. We have y-axis and x-axis. So on the gallery window, in the gallery window, you would be able to choose the type of chart you want to represent. So we have bar, histogram, scatter, box plot, so on and so forth. And then if you click on histogram, it shows different types of histogram. So we have simple histogram, stacked histogram, frequency, and population pyramid. Um, Remember, population pyramid is not just showing the population. We can use population pyramid for other types of uh, variables. And whenever we want to show the frequency of people or observations in different groups, we can also use population pyramid. So in histogram plot, we have y-axis and x-axis. The x-axis represents the scores. The y-axis represents the frequency of each score. Uh, we use histograms to identify any type of skewness, kurtosis, spread or variation in scores. We can identify outliers, unusual scores using histograms. We can determine the normal distribution of our variable, of our data points using histograms. So we have an example here. It's about Disney philosophy. It measures the success of 250 people, and we have success score range from 0 to 40. 0 is complete failure, 4 is complete success. And this is how it shows. So we have level of success on x-axis, and then we have a frequency on y-axis. So we can click on simple histogram, and it will show us a graph, a chart like this. And also we can change or adjust, modify the properties of our chart of our histogram. We can change the color, we can change the font size, font type. There are so many options you can you know work with. You can just play around and then choose uh, the color, the type, the font size, so on and so forth. So this is the resulting histogram, for example. So it says level of success after intervention, and we have frequency. It shows the mean, the standard deviation, and the sample size n. So this is a typical histogram. And the population pyramid, as I said, remember it's not just for showing the population of the number of people in a community, in a society. We can use population pyramid for that purpose, of course, but we can divide our data points into different categories and show the frequency of number of participants or number of observations in each category using population pyramid. So again, in population pyramid, you need to just click on histogram and choose the population pyramid. Again, you need to drag and drop your variables into y-axis, and it will show you the chart. So for example, we have hard work and wish upon a star. So these are different groups of people. On the right side, we have the group of hard work. On the left side, we have the group of wish upon a star. And the y-axis represents level of success out of 100. And the x-axis here is the frequency. So you can just flip the chart, and it will just a normal, like a simple histogram, but you have two categories, two groups of people. Box plots are another type of chart. It is very useful to show the median, the quartiles. That's for box. And the whiskers, it shows the range of scores, the limits within which the top and bottom 20% of scores lie. So for creating a box plot chart, again, you need to click on the gallery and choose box plot. And we have different types of box plots. So we have simple box plot, one-dimensional box plot, clustered box plot. Clustered box plot is useful for representing different levels of a variable. For example, male and female, or wish upon a star, hard work. So if you click on box plot and choose simple box plot, you need to again drag and drop your variables into drop zones, and it will create a box plot like this, as we can see from the screen. So as I said, box plot, it represents the median and the quartiles. So the black horizontal line in the middle, it shows the median, and then the box itself, the upper side of the box represents upper quartile, and the lower side of the box represents lower quartile. And then we have top 25% and bottom 25%. We can in box plot, we can also identify outliers, unusual scores. So we have extreme score outlier on the right side of the box plot. Error bar charts are very useful, very common. Unlike box plot, here the bar shows the mean score, not the median. And the error bar sticks out from the bar. It's like a whisker. It shows the uh, confidence intervals, 95% confidence interval, or deviation, standard deviation, or the standard error of the mean, depending on how we want to represent our data using error bar charts. But we need to mention it in a note or on the side of the chart that the bars the bars are uh, either standard error of the mean, these are standard deviation, or 95% confidence interval, for example. So for creating error bar chart, we need to choose from bar. We need to click on the bar, and then we have again simple bar, cluster bar, stack bar, 3D bar, cluster 3D bar, and etc. And we have like simple error bar. We have cluster error bar. So here's an example. Is there such a thing as a chick flick? So we have 40 people, 40 participants, 20 men and 20 women, and half of each sample saw one of two films: a chick flick, The Notebook, Control, a documentary about notebooks. The outcome measure is our y-axis. Our dependent variable is physiological arousal as an indicator of how much they enjoy the film. So we want to create an error bar chart or a bar chart. So again, using the gallery window, we click on bar and we choose either simple bar or error bar. On the right side, we can again work on the properties, the element properties. So we can choose, we want to represent standard deviation or standard error or confidence intervals. We can choose that here. And then we need to just, again, drag and drop our variables into drop zones. So this is our graph. This is our chart. So we have the notebook. We have a documentary about notebooks. So the x-axis is our group variable, which is the name of film or type of film. So here at the bottom of the chart, it shows error bars, 95% confidence interval. So as a reader, I can see that these error bars, which are sticks out of the bar, are representing 95% confidence intervals. And the y-axis is our dependent variable, our outcome variable, mean physiological arousal during the film. And for the clustered one, so here we have just only two bar charts, just two bars. But I can choose the cluster one, and I can divide. I can represent my data across across gender by sex, by male and female. So blue bar represents male, the red bars represent female. So I can easily compare the outcome variable across different variables across the name of film, type of film, and gender. And the repeated measures, we can use bar chart for repeated measures. Again, remember, repeated measures occur in experimental research. We have an intervention group, control group, or just one intervention group, and we have repeated measures of our outcome variable. So we measure our outcome variable at baseline, and then 3 months, 6 months, 12 months, 24 months, and etc. So here is our example, how to cure hiccups. So we have 15 hiccup sufferers. Each tries 4 interventions in random order. So we have baseline, we have tongue pulling maneuvers, we have massage of the carotid artery, and digital rectal massage. So outcome measure is the number of hiccups in the minute after each procedure. So I can use again error. I can use bar charts to represent to show my repeated measures. So again, I would choose the bar and the simple bar, and I can drag my variables into y-axis and x-axis. And here I can choose the properties of each repeated measures plot. So this is what I would see in my output window on SPSS. So I have 4 different interventions. I have baseline, tongue pulling, carotid artery massage, and the y-axis is my outcome variable, is my dependent variable, mean number of hiccups per minute. And here again, at the bottom of the chart, it indicates error bars represent 95% confidence interval. So as a reader, I can easily interpret this bar by knowing that these bars sticks out of the bar. Each bar represents 95% confidence intervals. They do not represent the standard deviation. They do not represent standard error of the mean. And also we can have mixed design. Mixed design is a design containing or consisting of qualitative and quantitative. So we have 50 children, and children is split into 2 groups, text messaging allowed, text messaging forbidden. And we can have each child measured at 2 points in time, baseline 6 months later, and outcome measure is percentage score on the gram test. So mixed design is kind of, I would say it's kind of a repeated measures, but we have different groups. So in this one, this is a repeated measures, but I only have one group. It doesn't represent the data by gender, by race, by education level, or whatever. But in the mixed design, I have the same types of repeated measures design, but here I split my data by groups. So here by 2 groups, text messaging allowed, text messaging forbidden. So again, I would choose the cluster one, the cluster bar, and drag and drop my variables into drop zones. I choose my element properties. So this is mixed design. So I have baseline and 6 months, and data is split into 2 different social media use groups, encouraged or banned. And the y-axis, again, it represents outcome variable or dependent variable, which is mean grammar score in percentage. Again, error bars represent 95% confidence intervals here. Scatter plots are useful in correlation and regression. It is useful for in numeric type data or variables. We will talk about this later when we talk about correlation and regression. So before running correlation or regression, we can run scatter plots and we can identify any kind of linear correlation or relationship between 2 variables. So for scatter plots, here is an example. We have anxiety and exam performance. So we have 2 variables. We have dependent variable and independent variable. Anxiety is our independent variable. Exam performance is our outcome variable or dependent variable. We have 103 students as our participants, And our measure is time spent revising, exam performance, exam anxiety, gender, for example. These are our variables. So for a scatter plot, again, in the gallery window, we can choose scatter dot, and we have simple scatter, 3D scatter, grouped scatter, summary point plot, and so on and so forth. So for a scatter plot, I click on scatter plot. I click on simple scatter. I drag and drop my variables into drop zones. And then I can also choose my element properties on the right side of the window. And this is the output from the scatter plot. So on y-axis is my outcome variable, is my dependent variable, exam performance in percentage. On the x-axis, I have exam anxiety, my independent variable. So each dot represents each data point, scores, observations. So these are, each cell is corresponding to cells in SPSS data file. And I have a line here. This line shows the best of fit model, and we will talk about that later. So from this scatter plot, I will say whenever the exam anxiety is, so here, exam anxiety is less on the left side. Whenever it's like 0 or 20, exam performance is much higher. Whenever I have a higher exam anxiety, higher levels of exam anxiety, I have a lower percentage of exam performance. So it's kind of, there is a negative correlation or relationship between exam performance and exam anxiety. And I can also create a cluster or a grouped scatter plot, which represents my data by sex, by gender, by race, by whatever. Again, I need to drag my variables into drop zones. So here, my x variable and my y variable are numerical. They are continuous variables. And here I have gender as my grouped variable. So I can drag and drop it into this small box here. And then I can choose my element properties on the right side of the window and then click OK. And this will show me the male and female. So this shows exam performance and exam anxiety, the relationship between exam anxiety and exam performance by sex, by male and by female. I can also create a matrix scatter plot. Matrix scatter plot is very useful when we try to represent our correlation in research articles. So a matrix scatter plot is kind of showing the relationship or correlation between multiple variables. So again, I need to click on scatter plot using the gallery window, and then click on the matrix scatter plot. Drag and drop your variables into drop zones, choose your element properties, and there you go. If you click on OK, this is your output. This will pop up in your output window on SPSS. So this is very similar to correlation table, and we will talk about that in correlation chapter. So we have A1, number 1, A, B, C is my rows. 1, 2, 3 are my columns. So A1, so it says time spent revising. And again, time spent revising. I don't have any data point here because I'm comparing the variable to itself. So I don't have any data point here. So for the row B and the column 2, again, there is no data point there because I'm comparing exam performance to exam performance. So it doesn't make sense to have a data point there. But whenever I try to compare exam performance column 2 to time spent revising row A, I can see uh, different data points here, and I can kind of interpret this. So my y-axis is time spent revising, my x-axis is exam performance. So whenever time spent revising is increasing, exam performance is also increasing. So there is a positive correlation here. But here I cannot interpret this because I don't see any p-value or any significance level. So I cannot say there is a significant correlation between time spent revising and exam performance. I need more data in order to interpret this as a reader. Or let's say row B, column 3, exam anxiety is my x-axis and exam performance is my y-axis. So whenever exam performance is increasing, exam anxiety is decreasing, or vice versa. Okay, I'm gonna show you how to download SPSS if you haven't already. So okay. So here on your computer, open your Google and then type SPSS UCA and then service SPSS download, request download, and then I have read, and so you need to check this box and then your name, department, and then submit. After submitting, um, it will send an email with links for PC, for Mac, and then if you click on those links, you can download SPSS. So let me show you SPSS. So this is SPSS. Let's say you download it, you install it, and you click on the SPSS icon. A blank window of SPSS data file will pop up. So here we have different options on top. So we have analyze graphs. This is our data view where my participants, like observations and different variables will go here. And then I have variable view. So I have name, type. So let's say I want to enter data here, for example. So first I need to use variable view, and then I will go back to data view and enter my data. So for name, I want to say study ID. It says numeric. That's numeric. The widths I don't need. I need just 2 widths. I don't need any decimal points. Label is study participants ID number, for example. I don't need to assign any number, and the measures is nominal. The second variable is weight, for example. Is it numeric? Width is 3. I don't need any, I need 2 decimal points, for example. I don't need to label it, and it's the scale, it's numeric. And then height, for example, it's numeric. I just need 2 widths, 2 decimal points, and it's scale. So I enter my variable names here. If I have a questionnaire, let's do this. Gender. Gender is, I would say, numeric. The width is 1. decimal is 0, and the width is 1, and the label is gender. So I can assign numbers to different levels of gender variable. So here, click on this small blue box, and then I can assign numbers to each level of my categorical variable. So I click on plus, the value is 1, it will be female, and then 2, it's gonna be male, and then click OK. And then let's say education. It's numeric. I don't need any decimal point. The width is 1. It is education level. And then again, click on this small box. I can assign numbers to my education level. It makes it easier to analyze it, to interpret it. So I click on plus bottom, and I say value is 1, label is less than high school. And then again, click on plus, add more numbers and values. Number 2 is high school. Click on plus. 3 is above high school, for example. And then plus. 4 is college, graduate. And then OK. So I can add more variables here. Fasting blood glucose level, self-efficacy, any questionnaire variables. So let's say I have a questionnaire, I have a survey, and I have question 1, 2, 3, 4, 5. So that's your assignment, but I'm gonna show you how to do that. So for questionnaire, I would say question 1. Here is a problem. Remember, SPSS doesn't recognize dash. You can put underscore, not dash. So question 1. So whenever you try to put question Q dash 2, there will be an error popping up. It says variable name contains an illegal character. So SPSS doesn't recognize dashes. You need to put underscore. Let me try space. I say body mass. It doesn't recognize space in your variable name. So if I want to say body mass index, I can put BMI, for example, or body underscore mass underscore index. So SPSS doesn't recognize space, doesn't recognize dashes. Let's try another type. Let's say fasting dot blood. It recognizes it. So that dot is okay, but S space and dash is not okay. Space doesn't work in that way. Okay, so let's say I put a variable here and I want to delete it. It was wrong. For example, fasting.blood. I don't have any variable called fasting.blood. So I need to click on this number 8, right click, clear. That's all. Body mass index, I can also do something like this, Control C and then Control V. Doesn't work. I don't know why. Control C, Control V. Okay. So the variable name is not working as Control C, Control V, but I can do Control C and then Control is like copy and pasting for other columns. So let's clear this. Let's clear body mass index. So question 1. So let's say I have a survey and it's a Likert scale. It's from 1 to 7 or 1 to 5. Strongly disagree, disagree, neutral, agree, strongly agree, for example. Question one is like that. And then I can type the label of question. For example, oops, how confident are you in something? The rest of the question. So that's my first question in a survey, in a questionnaire. And then I assign values to the responses. So again, click on the small blue box, click on the plus sign and the value. So number one, if they answered strongly, strongly disagree is my number one. Number two is disagree. Number three is neutral. Number four is agree. Number five is strongly agree. I have typo error here. Okay. And click OK. And then the next question, question two. And here I can change, like with the scale, for example, strongly agree, strongly disagree, um, favorably, unfavorably. These are ordinal, so I can change the measure to ordinal. Okay. So let's go back to data view. So here I would say 1, 2, 3, 4, 5, 6, 7, 8. Hmm. Okay. And then weight, for example, says 85 kilograms, 76, 68, 43. This is too small. 59, 100, and etc. Height, something like this. Let's say it's like 60 inches, 67, 68, 59, 58, for instance. And the gender, I have assigned value. So participant one is female, so it's one. Second one is female. Third one is male, 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 one, one, so female. Education level is less than high school. It's college graduate, 3, 2, 1, 4, or 3, 4, and etc. And then question one, it's like strongly disagree. It's 9, 1, 2, 1, 2, 4, 5, 4, 3, 2, 1, and etc. So this is how I enter data into SPSS. First, I use variable view to kind of enter my variable names, their types, their um, measure type, and etc. And then gender is also nominal, education is ordinal. And then after that, I enter my data. So let's say I'm finished with data and I want to save it. So file, click on file and then save as, and then choose your path on your computer and then save. I want to show you one more thing. So this is how to enter data into SPSS one by one, but I can also import data from Excel file or data or Google spreadsheet. Sorry. Okay. So I can click on File, Import Data, Excel, CSV data, SAS data. So I can click on Excel file and I can choose an Excel file using my uh, local folders and then open. This is how to uh, import data into SPSS. For the graphs, you need to click on Graph Chart Builder. Okay. And then here I have my variables I already created. Here on top, I have variable names I already created. And then I have gallery, so I can choose like histogram, bar, scatter plot, box plot. So let's do histogram. I want to do a simple histogram. So I double click on it. Then I can grab and drop my variable into x-axis and y-axis. So let's say I need to have um let's see. I want to see is there any I want to see the frequency of, let's say, maybe not sure, maybe gender. Let's see how it works, for example. And then element properties, you can choose the color, uh, chart appearance, the color, more options. Here you can choose the confidence interval, standard error, and standard deviation. Let's do this. Let's see how it works. Okay, so um, this is the output window on SPSS. This is totally separate from SPSS. It's a separate window. Um, so here I have female and male, and this is my frequency, study participant ID number. So this is how it works. And then I can just close it. No, graphs, chart builder. Let me add a variable, and then we can do a good histogram of that. So let's say, or other types of chart. Let me complete this and I will. Okay. I'm gonna do a scatter plot. Okay. So I wanna choose a scatter here, simple scatter. Um, okay. So I'm gonna do a scatter plot of body weight and height. Click OK. So this is my scatter plot. These are data points. So I have 8 observations, 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 rows, 8 participants, and each blue dot represents individuals. And then I have height on x-axis and weight on y-axis. So and if I click on double click on the table, on the graph, on the chart, it will open an additional window, and I can also work here on the scatter plot. So I can choose, let's say, it says fit line. Linear, 95% confidence interval. Um, Fly. So here this is the fit line. This is how it works.